Bismillahirrahmanirrahim. Um, and Assalamualaikum to all and examiner. My name is Fatin Nadhirah binti Abdullah, and my supervisor is Dr. Haslina binti Hashim. My final year project title is Identification of the Strongest Multi-Omic Biomarker for Lung Cancer Classification. The points that I will talk about in this presentation includes all the chapter inside the FYP, which is Chapter 1 Introduction, Chapter 2 Literature Review, Chapter 3 Research and Methodology, Chapter 4 Research Design and Implementation, and Chapter 5 Conclusion. Okay, for Chapter 1, for Introduction, my domain of interest is lung cancer. So the lung cancer is the most leading cause of death after heart disease, which is contribute to 18.4%, around 9.6 million of deaths in 2018, and then this statistic is obtained from WHO, the World Health Organization. The lung cancer is also the main causes of death of both gender, which is the male and female in the world, and it can be categorized into a malignant or the cancerous tumor, because it can spread or invade the surrounding tissue via bloodstream or lymphatic system. And it has two types, which is small cell lung cancer SCLC and non-small cell lung cancer and SCLC, which the SCLC is more fatal or severe than the NC and SCLC. And then of course the causes of the lung cancer is because of the long-term smoking with minimum 30 pack per year, and then this apply to the long-term smoker. And then it is also hard to diagnose the lung cancer at early stage. It's usually been diagnosed at stage 3 or 4. The problem background of this research is the lung cancer is hard to detect because it's hard to detect at early stage because of the faint symptom, which can delay the early treatment of the patients, thus can decrease the survival rate of the patients. And thus, the multi-omic biomarker can help to identify and classify the general or specific type of cancer, which can help us to detect the lung cancer at early stage, which is the stage 1 or 2, and can increase the cell survival rates of the patient because they receive early treatment. Okay, next, for the aim of this research is to identify the strongest multi-omic biomarker for lung cancer classification by using multi-omic data with feature selection and multi-omic approach. The objective is to identify the method that can be used for feature selection to identify the strongest multi-omic biomarker for cancer classification, to implement the feature selection in order to identify the strongest multi-omic biomarker for cancer classification, and the next is to evaluate the effectiveness of the chosen method for multi-omic cancer classification. And then the scope for this research is research will be using a lung cancer dataset from TCGA dataset, and then the pre-processing of the dataset will be conducted with Python 3 in Jupyter or Spider. And then the performance measure that is chosen is the classification accuracy for the cancer classification, and then the SVM, sample vector machine, is chosen for the cancer classification and will be using a feature selection to filter the data for a better classification performance. For the Chapter 2 literature review, the feature selection based on my studies on the literature review and findings, it is a method used to improve the accuracy of the outcome, and it also help in data understanding, can help to improve the classifier performance, and also it can tackle a high dimensional dataset problems. And then it also can remove the irrelevant and redundant features from dataset, which can enhance the data quality and speeding up the data mining algorithm. And the feature selection has 3 types, which is filter approach, wrapper approach, and embedded approach. Okay, for filter, it has a low computational complexity, and then it also have fast and independent from classifier. And then wrapper, it has a better classification than filter approach because of its specificity toward a given classifier. And then the embedded, it can take advantage of the model properties, and then it also can analyze and identify the problems and then select the most important features in the dataset. Okay, for the filter approach, it has three common types, which is the relief F. It can reduce the computational complexity time. CFS can find a highly correlated features with the classifier, and then MRMR it has a strong robustness and fast calculation. And then for the classification, the support vector machine SVM, it will map a vector or predictor into a higher dimensional plane, and then it's defined for a binary classification of a numeric data, which is the SVM is very useful for a binary classification or binary data, and then it can provide a high quality data classification performance. Random forest ensemble learning of classification, and it will merging a large number of simple classifier. And then next is logistic regression, which can represent the probability of the occurrence of one or more or two classes is in dichotomous criteria. Also explain the relationship between one or more binary independent and one independent variable. Next is chapter 3, the research methodology. For the research framework, this research contains 4 phases, which is phase 1, the initial study. In this study is the chapter 1, the introduction, which we will define the problem statement and problem background, define the objective and scope, and dataset collection. Next is the phase 2, literature review, for the collection of resources and studying the domain of the research. And the next, and also to study the general type of feature selection and classification. And for phase 3, the design and development is to design and improve SVM RFE with MRMR for better classification accuracy, and also to develop the improved method and also to testing the improved method. Phase 4, analysis and discussion, will analyze the result that we obtain from the MRMR and SVM RFE technique, and then we will compare the result with the previous existing results about the accuracy of the combined multi-omic data. Next is data source. The data source of this research is the lung cancer dataset. It can be obtained from the Cancer Genome Atlas TCGA programs, and it has 4 types of lung cancer dataset, which is the methylation, gene expression, microRNA, and survival. Next is the performance measure. The performance accuracy has been chosen for the performance measurement, and then the accuracy is one of the measurement inside the coefficient matrix. Will help to identify the effectiveness of the proposed method from the accuracy. And then here is the formula of the accuracy. Chapter 4, research design and implementation. The proposed solution is using the MRMR feature selection with SVM RFE, and then we will use MRMR to remove the redundant and irrelevant feature in dataset, and use the SVM RFE for better classification task. Okay, why use MRMR and SVM RFE? Because MRMR, it can give a better classifier performance results for the classification, and then it can sort the feature according to the criterion of the max relevant, which the higher relevant feature will rank higher, which can ease us to select the best feature from the output list. And in the SVM RFE, it is more robust, especially for overfitting data, which is the multi-omic data such as methylation, gene expression, it contains 100 or 1000 of data, which can cause the overfitting of the data. And it can remove any less relevant features recursively. SVM of the SVM RFE will provide high quality data classification performance. For data preparation, we will convert the data into .csv, which is the comma delimited file for all dataset with Microsoft Excel, and then we will load the data into Python by using the spider. And then for the data pre-processing, it includes 6 processes, which is data rescaling, standardization, normalization, binarizations, analysis, and visualization, which all these processes can help us to reduce the data mining algorithm, can reduce the time, and then it can eliminate all the data redundancy, and then it can make the classifier more efficient. And also it is important because it can fetch some important information such as standard deviation and mean. And it's also good to visualize the dataset, so it can make us more understand about the complex relationship inside the dataset. Chapter 5, conclusion. The first objective of this research has been achieved, which is to identify the method for the feature selection for cancer classification, which for this project I choose the MRMR feature selection and SBMRFE for the cancer classification. And for the second objective of this project is to implement the chosen feature selection, which it is partially achieved because all the pre-processing has been done, but the feature selection and the classification has not been done yet. And then we will do the evaluation of the effectiveness of the feature selection, which is also has not been done yet because there's no implementation done for this stage, and then that will be done in PSM2. And then the future works for this research is for the next PSM2, we will do the implementation of the proposed method, which is the MRMR feature selection and SVMRFE for the lung cancer classification, and then we will find the best combination of the multi-omic biomarker. The best combination of the multi-omic biomarker will be identified, and then the discussion of the lung cancer classification and combination result also will be discussed. And then for the really future works, maybe another combination of features and classification also can be done in order to improve the result. That's all from me. Thank you.